become drug resistant or make them become more invasive. This is all requires effort to study more. Yes. Okay. More questions? All right.
Dear Professor, I would like to ask about the ABC Connect.
Yes.
At the end of the interface, the ABC Connect combined to the CDX1, but before the ABC Connect to combine to the CDC20. But the question is that why at the beginning the CDC20 combined to the ABC Connect, but what factor made it really wrong the ABC Connect to?
Okay. Yeah, there's a bit. I just give you the picture there. I think maybe the picture require more literature study when you have a chance. Okay? But basically, these spindle fiber attachment really trigger the recruitment of all these different proteins into the kinetic pore. Okay? Sometimes you see the CDC20 is out. Sometimes you see the CDC20 actually recruited through the interaction with BAP1, BRBR1, and other MET protein. Okay, so this is a very complicated process. But the idea, the bottom line, because I don't want to go into much detail, because you may much more confused. Okay? The idea, the bottom line you should take home is that the APC is inactivated when the spindle fiber is not attached. And then this process in BAP1, BAP1, MET1, MET2, CDC20. Okay. And so hopefully these give you a inspiration, so you could dig out more literature to understand more. Okay. Which you finished? Are you in master program now, or you are still in college?
I'm a master program.
Yeah, master program. Good. So you should have the capability to start searching for literature to read more about this process. Okay. And I hope this lecture is inspirational for you to study more. I think if you ask that question, meaning you really want to know what the detailed study about all these processes. Okay. Okay. Last question before we that one. Okay.
Professor, I have a question because you say that ABC complex just activate in the anaphase, but I see in the picture an ABC complex activate before to ubiquitin cyclin A. I don't know why. And
yeah, good eyes. You catch that. When I say ABC, what I should say ABC CDC20 complex is not activated when the spindle fiber is not attached. Yeah, I should say that. True, the ABC was able to degrade other type of protein because the ABC is an E3 ligase. They may depend on what adapter they have used, be able to use different adapter to degrade either cyclin B or securin. APC, if they're using other adapter other than CDC20, they will be able to degrade other type of protein. Yes.
And another question is, how about I knock down ABC complex? What happened in the anaphase because serine and cyclin B is not ubiquitin to degrade, so the DNA show the chromosome still blocked, and can it will block the cancer cells? So it will block the cancer stem cell to replicate, divide to another cell, so I will destroy the cancer cell.
Okay, so his question is about knockout APC complex, any one of them. What the consequence of that? And this consequence has any impact on cancer stem cell, right? Is that your question? Knockout APC complex, you could imagine you will compromise the APC's capability to degrade either cyclin B or securing, or maybe Aurora A, Aurora B, etc., PLK, these different kind of protein. So the whole mitosis will screw up, okay? As for these could cause any consequence about the cancer stem cell or not. If cancer stem cells start proliferating, they will be affected as well. But if not, maybe it's nothing to do with cancer stem cell. Okay? So it just depends on what context you try to ask these impact on cancer stem cell. If at the beginning you knock out at the beginning at the embryonic stage, you know, maybe the mouse or embryo couldn't survive more than couple cell stage. Okay. But this is APC, you know, is very important during the mitosis process, for sure. Okay. Good. All right. Let's start to the next step. We talk about APC here. Okay. So the APC you can see here is a very complex protein complex. They have several things. APC2, okay. There's an APC11, there's an adapted, okay. And then a whole bunch of these are other protein, APC1, APC5, you know, etc. And they have this adapted, be able to combine with several other type of protein, including CDC20, including the SCD1, or sometimes with CDH1, and then they have an individual target protein. Okay. For us, other type of E3 ligase is also present. Okay, this is we call it SCF again. The SCF complex is composed of SKP1, CDC53, or sometimes we call it choline, and the CDC34. This is the E2. Okay, but basically S, C, and then F. Okay, these are all F-box protein. Remember, was all in the yeast system. So you sometimes you get a name of these kind of strange name called GR1 or CDC4. These are all F-box protein, okay? And they could regulate individual substrate for their regulation. So that's the reason I say the original study in cell cycle was done in yeast a lot. And then all these 3 Nobel Prize winners, basically they were doing the yeast genetic study. Okay, so now you get a name, all these CDC, it's based on the yeast genetic study. CDC stands for what? Cell division cycle. Cell division cycle. Okay. CDC, coming from the yeast genetic study. Okay. Yeah, so you heard about CD34, sometimes mammalian gene, you also using that name. In the yeast, the CDC53, in the mammalian cell right now, we call it choline. Okay. Here, give you the flavor of all the E3 ligands, okay, potential E3 ligands. There's an APC compound we talk about a lot, okay. The APC2, APC11, CDC20, or CDH1, causing the cyclin B degradation. SCF complex, this is coming from the yeast. They have these SKP1, choline-1, F-box protein, okay, to target the target protein SIC1 for degradation. This is go through the E2 or sometimes go through the, in this case, the UBC is the E2 enzyme as well. And the VVC complex, okay? This was involved in the Carlin-2, okay? As the elongin BC and the VHL. VHL, remember this is a very important tumor suppressor gene for von Hippel-Lindau, okay? It was involved in renal cell carcinoma. Okay? And then this is very important E3 ligase to regulate HIP-1 alpha stability, okay? As you can see here. Give you another one, the E3 ligase for SCF, even much more because it much come with different flavor as well. So Carlin, we have Carlin-1, Carlin-2, Carlin-3, Carlin-4, and 5, etc. And each different Carlin may be associated with different partner. For example, CAL1 was associated with SKP1, and then with the F-box protein. Okay? And F-box protein has a motif to recognize substrate. That is for S, C, F. Okay? SKP1, CAL1, F-box protein for SCF, and they sometimes interacting, associating with a ring-containing protein for the whole SCF activity. For Carlin-2, we talk about elongin B and C, very similar to like SCF complex. This is Carlin-2 and 5 for elongin C, just like SKP1, elongin B and C. This is for substrate recognition. Basically, these complexes will recognize that HIP-1 alpha to causing HIP-1 alpha degradation. HIP-1 alpha is very important transcription factor. Stands for hypoxia-inducible factor. HIP-1, hypoxia-inducible factor. The Carlin-3 have the one adapter. It's BTB containing motif. Okay, there are organizations like this to recognize certain substrate. The Carlin-4 interact with another adapter called DTB1, DNA damage binding protein 1, to recognize certain substrate. Some of these are not very well studied, not very well known. The majority, we know more about this complex. Okay, so again, this is still a wide open field. Remain to be characterized. We know about Carlin, as I mentioned. Carlin has a CAL1, CAL2, CAL3, 4A, 4B, 5, and 7, etc. They have all these different partners. Okay, we already briefly mentioned it. Okay, and there's impact on the different biological function. It's right now start appearing. And then the structure of an SCF E3 ligase has been determined because the structural biologists help us understand how these proteins could recognize their substrate. Okay? And then this SCF complex, the structure has been determined by structural biologists through crystallography. Okay? The crystallography determines how the structure of the Carlin here, and you can see here, Carlin have these domain to interact with the SKP1, and the SKP1 interact with the SKP2. This is the F-box protein, and then it will be able to recognize the substrate. The Carlin-1 has this part of be able to associate with the E2 enzyme and then associate with the ring domain containing protein. And importantly, there's another attachment site for NADDA. NADDA is a short peptide, just like ubiquitin. It's very important for the SCF complex activity because the attachment of the NADDA determines the SCF activation. Okay, and you can see the structure, the distance of the one domain and the other domain has been determined. here, based on that structure, has been shown here, that CAL1, as you can see here, and there's a ring domain containing protein called RBX1, and there's a motif for these calling to interact with the E2 enzyme. The SKB1 is here. The F-box protein, this could be the SKB2, will be able to allow the whole complex to recognize a substrate and allow the E2 to transfer ubiquitin onto the enzyme. Okay, it's shown here. SKB1 F-box protein has a ring domain containing protein here, has an E2 enzyme here. Okay, the E2 enzyme will transfer ubiquitin onto a substrate that has been recognized by F-box protein. Okay. This is what SCF. You want to look at the CAL2 complex. This is CAL1 complex. This is CAL2 complex. It's a CAL3 complex. Very similar organization. So basically, you get an idea that it's such a complicated process that requires several proteins to recognize one protein for degradation. Okay? Here, the linker, the ring, the adapter, all shown here. It's very similar to what you see here. The linker SKB1, adapter, F-box protein, the substrate is this guy here. And then with that methylation on the calling, require for these calling 1 to cause the downregulation of a certain substrate. So here showing you again the CAL1 complex. Recognize using the SKB2 and F-box protein, recognize P27 for ubiquitination and degradation. Okay? And then the next one using CAL2, the elongate B and C is basically like a SKB1. Using VHL as the E3 lipase component to recognize HIP1 alpha for HIP1 alpha ubiquitination and degradation. CAL3, BTB containing adapter, recognize Aurora B for Aurora B degradation. These CAL4A-B using DDB1, and then another adapter to recognize CDT1 for CDT1 ubiquitination and degradation. ABC2, ABC complex, we talked about that many times. Okay, using the ABC11 like a ring domain containing protein, using CDC20 or CDX1 as an adapter for degrading cyclin B, because encoding cyclin B, ubiquitination and degradation. Okay. So this gives you a flavor that even just these E3 ligases are so detailed, regulated, with different components to form a complex to degrade certain type of protein. Okay. The CAL2 enzyme, would this degrade P27? Usually not. Okay. Because they need using certain adapter for certain substrate degradation. We talk about cyclin D degradation, but here I would like to introduce you the cyclin E degradation. Cyclin E degradation was degraded by SCF complex as well. Again, you see the SKB1. Okay, and then F-box protein here. Okay, F-box protein hook up. This F-box protein is called FBW7. Okay, FBW7 stands for F-box protein containing WD40 repeat. What is WD40 repeat? WD40 repeat is a propeller-like structure like this. You take a look. If you look at the other side, it looks like propeller of the boat of the, the structure will be able to recognize the substrate, cyclin E there. Okay, you see that these are FBW7 using the WD motif to recognize cyclin E. Okay, the sequence is shown here. the cyclin E has a certain sequence will be recognized by the WD40 motif. Okay? And then FBW7 using that motif to recognize not only cyclin E, but also MYC, also June, Notch, etc. Okay? So these FBW7 is very important tumor suppressor gene because it was able to cause the degradation of cyclin E. If certain type of cancer has cyclin E overexpression for degrading MYC, C-Jun, Notch, these are all oncogene. Okay? And sometimes the cancer has a way to manage it, to make FBW7 has a mutated form. Mutated where? They are mutated some place around here, so they will not be able to recognize cyclin E anymore. They will not be able to recognize C-MYC or C-Jun. So see how a cancer cell will manage to escape the activity of FBW7. This is for cyclin E degradation. Let's take a look about F-box protein and FBW7. This is gene structure of FBW7. Okay? FBW7 has actually 3 different kind of isoform due to the different gene splicing event. Okay? They make it an alpha form, a beta form, or gamma form. So the alpha form here, okay, and then they all have these and a beta form here, the gamma form here. The common structure of the substrate binding domain, they have these propeller structure of WD40 motif. Okay? They recognize the substrate. They have a dimerization domain. They have an F-box motif to interact with SKB1. These different isoforms have different subcellular localization. As you can see here, the FBW7 alpha form majority is located in the nucleus. The beta form majority is located in the cytoplasm. The gamma form is located in the nucleolus. Okay? So different isoforms have different subcellular localization, may have a different target. Okay? Now we'll come to a little bit experiment again, how to study these isoforms on cyclin E degradation. Okay? Again here, another pulse chain experiment. Okay? And then the scientists will be able to manage to degrade alpha form gene or beta form gene or gamma form gene. And now you take a look, okay? Alpha null cell, okay? The cyclin E, the turnover rate, it's been stabilized. But not in the beta form null cell or gamma form null cell. The cyclin E is short half-life protein. This cyclin E got degraded following the time course. This cyclin E got degraded following the time course, but not the alpha form null cell, suggesting that alpha form is the one responsible for cyclin E degradation, right? We talk about knockdown. Sometimes people using siRNA rather than shRNA. Si stands for small interference RNA. Okay, you could knock down either alpha form or beta form or gamma form. Okay, but you take a look. Okay, about the regulation of the cyclin E. If you knock down alpha form, cyclin E compared with the control, it's elevated compared with the control, but not beta form or gamma form. Okay? And then this was done into 2 different cell lines. One is the HeLa cell, one is the 293A cell. HeLa cell is the cervical carcinoma cell line. Okay? 293 is the human embryonic kidney cell. So they all have a similar observation. When you knock down alpha form, cyclin E got elevated compared with the gamma form or beta form. Okay. These suggest that alpha form is the one responsible for cyclin E degradation. So we talk about the cyclin, the ubiquitin conjugating require ATP. Here they have done this so-called in vitro ubiquitination process to tell you FBW7. FBW7 has another name in yeast called CDC4. It's involved in cyclin E ubiquitination. Okay, so basically, they have added up ubiquitin into the reaction, E1 enzyme, E2 enzyme, and ATP, plus, okay, the SCF complex, including SKD1, CDC53, or RDX1. And then here,